What do spacecraft have in common with your MP3 player? More than you might think. For decades, satellites and spacecraft relied on magnetic tape recorders to record and store data. Unfortunately, tape-based recorders have moving parts which are vulnerable to breakdown. In the early 1980s, Colorado entrepreneur Ray Anderson teamed up with his sons and started a company to develop alternative solutions. Seakr Engineering's first goal was to develop a replacement data recorder for a weather satellite. They came up with a system that was smaller, more dependable, and used less power than tape-based systems.
Back then, the idea was we could replace that tape unit with a solid-state equivalent and put lots of these together, just like the RAM in your computer, and replace these tape drive systems. And so it was truly a novel concept of using a solid state to replace a mechanical moving device.
In 1992, the company began working with NASA. Through a Small Business Innovation Research, or SBIR award from Goddard Space Flight Center, Seakr developed a solid-state recorder to replace the tape recorder on the Spartan satellite. The partnership resulted in a flash memory unit, similar to the type of memory in some of today's modern portable media players, which recorded data from an inflatable antenna experiment deployed on the Spartan platform during STS-77 in May 1996. With the expertise gained from designing solid-state recorders, Seakr Engineering soon expanded into other areas of electronics, specifically built to withstand the rigors of spaceflight. Hardware from the company has flown on numerous NASA spacecraft, including planetary probes, satellites, space shuttles, and the world's largest orbiting laboratory.
We built a large data router for the International Space Station called the H-Core. It stands for High Rate Communication Outage Recorder. And it actually acts as a large data switch on the high rate data link bus on station. So it allows all the different nodes within the station to route their science and communication data to one large memory buffer.
The firm's work in the field of space-based electronics has also led them to offer more down-to-earth solutions, including solid-state flight and data recorders for aircraft. And now Seakr is developing another type of space-based technology to enable voice, video, and data communications between satellites using standards developed for the Internet. The firm is partnering with Cisco Systems on a space-hardened router. The equipment is being designed as part of a Defense Department project to test IP routing on satellites. By enabling onboard processors to route the up and down data links, communications will become faster and more flexible. Eventually, this next generation of space communications may allow U.S. soldiers to access timely and accurate information in the field, as fast as you dial up a playlist of your favorite songs.